Are you sure you want to start the live event now? Yes, I am. Hello, everybody. Welcome to our talk today, the Improving Lunch and Learn. Before we get started, I want to inform you about the Q&A feature. There's a question mark icon at the upper right of the presentation screen. Clicking that icon will open the question and answer feature, which allows you to send the moderator questions to be delivered to our speaker at the appropriate time. With that, we're excited to have Tim Rayburn here, Vice President of Consulting and Improving. He'll be presenting this talk today titled Architecting for Retirement. Thank you, Tim, and the floor is now all yours.
Well, thank you very much, Jeff. I appreciate you moderating today. All right, welcome everyone. Today, we're going to talk about a topic that I very much am passionate about, and it is this concept that we want to build software for its own retirement. Okay, we have a habit when we get into greenfield opportunities, when we're like, hey, we're going to go start something new and we're going to go build something, that we are thinking too much about the here and now, the cool new things we want to add to it at the moment. And today we're going to instead talk about, I want you to think about the fact that that software will eventually go away and how you set up your future self for success to both delay when that point is so that we don't have to retire as quickly, and to make it so that when that occurs, there is more usable for the system that follows it. So with that, let's jump in and talk about this a little bit more. So first truth, perfect doesn't exist and everything eventually fails. I don't care how pristine your vision is, how beautiful you believe this new system that you're developing is going to be, it will eventually fail. It will eventually need to be replaced. So we need to be real about that up front. And we need to have discussions with the business up front about what the expected lifespan of this system is. Because that is so critical from a business point of view to decide what is worth investing. Now, we're going to do our best. We're going to forecast and have a conversation about what things are going to affect the lifespan of this application. But I think the reality is that we don't start on the right foot with business most of the time. We start with, we're building the new cool thing. We're not being straight that we need to talk about the fact that this will eventually retire. And we need to talk about how many years of operation, hopefully years of operation, they're going to get out of this piece of software before they hit the point of needing to rewrite it or revisit it. Now, you're going to do your best. You're going to forecast this. Sometimes you will be right on the short side. Okay, sometimes you will be like, okay, I predicted 5 years, and in reality, we only got 3. Unfortunate. Sometimes you'll make a prediction, and it's like, okay, this is good, likely to be good for the next 5, maybe 7 years, and you will become the AS400 of software development. You'll be the application that's still in production 50 years later. But I'm here to tell you the AS400 systems that still drive an absurd number of businesses out there in the world today didn't get there by accident, and they got there by paying attention to several of the things we're going to talk about today. So the reality is that most systems that retire actually retire because of the fact that we've hit a lack of trust. A lack of trust in a particular system is the #1 reason why systems retire. You probably don't think this. You probably don't even think about how trusted your systems are. But as we're going to go through this in a moment, I want you to look at all of the phrases we're going to use about software systems and why they're retiring or why we're doing massive changes to them. And I want you to listen for those things where really this is just, we can't trust this. Okay, because I think you'll see there is a major tie through, and this goes back to Improving's brand promise right up the start that trust changes everything, and that Improving is trying to build environments of trust every single day. Yes, that has to do with interpersonal trust, but it also has to deal with trusted systems. And this is absolutely one of those places where I want people to feel like they can trust the IT systems that have been built, then know what to expect from them. If what to expect from them is going back to that first conversation of we've talked about when this is going to retire, if the what to expect is this is going to run for 3 months, get the job done, and then we're done with it, fantastic, as long as we were upfront about that to begin with, right? We talked straight, we talked about what it was going to take. There was no focus on get better on this one. This was just like get it done, get it out there, and then we're going to retire it. Great. Like, that's fantastic. That's a perfectly valid way to go through things. So whenever a system does retire, this is the big thing. We're going to talk. When it's done, when you're like, it's time to retire this system, what pieces of the existing system are going to be relevant to the next system that is going to be built? This is, in my opinion, the number one thing no one thinks about. How can I design for today for creating a situation where I hope, because it's forward-looking, I don't know for sure, but that I'm at least setting up the likelihood that pieces of what I'm building today would be useful to the next system. And in an ideal world, we would have it to the point where whole systems that I have built are relevant to the next system. This is really then not like a ground up rewrite. This is more like a, hey, we're evolving, moving forward to a major new version. That's sort of ideal. And then as we come down, it's like, okay, not whole systems, but maybe component pieces of it can be reused. From there, if you're reasonably good at your game, maybe you have automated tests which are capable of testing the system as a whole that would be useful in testing its replacement. Failing that, you're going to hopefully at least have requirements that come out of the software development process that are core to your business. They describe what your business, how your business does business, and as such, they would be useful to informing the next system. And then finally, you get to the point of absolutely nothing being usable. Well, unfortunately, development teams, development organizations very quickly just run down here. They go, nope, none of this is going to be useful. And they declare bankruptcy on the existing system, leaving all the value above them in this pyramid behind. Now, I've written a thoughts blog previously on the improving.com site talking about the whether or not you should do the complete reboot, or whether or not you should try to incrementally change towards your future vision. And I'm not saying that it is always a better idea to incrementally change than to do a massive greenfield effort. But I am here to say that in my experience, the incremental change is a viable option far more often than the humans involved are willing to give it a chance. And the reason is almost always emotional baggage, where they've suffered under this system. They blame this system. The system didn't do anything. The system is just a system. It has no personality. It didn't interrupt your family vacation when it went down in a catastrophic heap. That wasn't the system's fault. That was your business's and your department's fault that it wasn't maintained and kept at that level to be robust enough to avoid those situations. But we like to blame the inanimate rather than own it ourselves. And because of that, we have this tendency when we get to this retirement discussion of what is usable after the retirement, that we wind up running immediately to, well, then obviously none of this is useful, right? This is just a pile of trash at this point. It's not a pile of trash. It's a system that's actually paid your paycheck for likely years. Okay, so we need to be more honest and say incremental change towards an ideal future vision is a better idea than most people are going to give it credit for. So pause, think about it. Go read my blog article if you want to get into more details about how you would evaluate whether or not these two options are viable back and forth. Now, we've gotten through this. We're now to the point of how do systems fail? So I've given you several phrases here that we're going to use to talk about things, because again, I think that systems fail because of a lack of trust in them, and these systems are failing because we're saying these things about them. We believe these things about them. We believe that we're afraid to change the thing. We believe that no one even knows how it works, that we don't know why it does this to begin with. Then we have it isn't fast enough. This one's very common, right? And then finally, this is built on old technology. And so I'd like to go through and talk about the things we can do at the start to avoid these things being said about our system eventually. So let's walk through and start with we're afraid to change things. So I understand that every system of any reasonable complexity probably has the "there be dragons" section of the code. I have maintained an open source project with my good friend Devlin Lyles for many years. And in the heart of our test harness, actually, is a piece of code that handles a directed acyclic graph. You can look it up on Wikipedia, but the short answer is it's a way to manage a large number of loosely connected things and know whether or not something has been orphaned off and is no longer needed. And that piece of code, when it was originally written, was flat out, it was written by Devlin, and flat out, only Devlin could understand it. This is absurdly deep and complex. And I've seen much more complex, much more difficult pieces in the actual business realities of companies that I've worked with in healthcare, in oil and gas, that have really deep, complex business rules that they get obtuse. And so how do we avoid making it so that we will eventually wind up with the "we're afraid to change this"? Well, several things come to mind here. First of all, comments. I know that comments are a code smell, yada, yada. No, not for complexity. For really complex things, comments are godsend. And this is something that I think comments get a bad rap because of the fact that they're often misused by the comment above an if statement that merely restates the if, right? And I understand that those comments are probably not worth the keyboard strokes that were used to create them. But when we have true complexity, we need to be able to explain the true complexity. The big pieces of this are actually, to me, are you describing the purpose of a unit as a whole? Are you describing the purpose of the class or function that you're writing as a whole for what it is meant to do? Because I think these fear of change, the fear of getting into the complexity, is that we fear that it's going to take endless amounts of time just to understand even how it does its job today. So summarize how it does its job. The next piece is, this is where automated integration tests come in. If you have complexities, complex pieces like this, if you have something that is just technically complicated, test the crud out of it and make those tests clear as to what they're doing and what business scenario they're solving. And then finally, documentation. Again, I'm an Agile software developer. I'm a fan of the Agile Manifesto, but I believe that far too many people read the Agile Manifesto where they say we prefer X over Y, and when Y is documentation, they go, well, so we'll never do anything. We'll always prefer working software, and we only want to do working software. We never want to do documentation. That's not true. Documentation has its place, and in particular for deep, complex things, it is worthy of spending some time and writing the documentation, even if it's a README markdown file in the repo going, hey, if you're here, go read this. That documentation is worth it. Explain to your future employee how this will work. Because in an ideal world, you're not in this same role when this system is being retired. You need to think generationally. We are most likely writing systems in the modern era whose lifespans are years. This is why I said, let's talk about lifespan at the top, right? But if you're talking lifespan in years, right? And you said, hey, we believe this is a 5 to 10 year lifespan on this product. Let me ask you, do you intend to be in the same seat in 5 to 10 years? I bet the answer is no. So let's not pretend that we will be. Let's prepare for the person who was not here when we wrote it to be able to understand what is to follow. So the next phrase that we had was, no one knows how it works. Well, again, this is a variant of the above, but this is now, hey, do we have automated unit tests, right? Let's talk at the unit level, how it works in detail. That's what unit tests are about. Do we have automated deployments? Does the code know how to deploy itself? One of the things I love that I am somewhat of a zealot advocate for inside Improving is that deployment scripts, the how of deployment, should be checked in with the source code, because deployment systems are starting to make the turn now finally to the reality that I have been explaining to Improving dev teams for years, of the fact that if I have code and I have a DevOps system that lets me modify things, and I've changed things over time to how things are deployed, if I jump back and need to redeploy code to a year ago, do I even know how to do it? My DevOps system doesn't anymore, most likely. The traditional system doesn't keep that sort of history. So those pieces of how code is deployed should be in your repository. Your code should know how to deploy itself, and you should then have it so that those deployments can happen automatically. Now, your environment, I know it always scares people when they hear the words automated deployment and they're like, whoa, we can't possibly go to prod. All right, I will leave that to your business scenario. I can't know your particular scenario. I will say there are safe ways to get to prod for far more businesses than believe they can. But with that said, fine, let's go through and simply accept that we should know how to deploy things, because a script that codifies how things are deployed, that you get to no hands deployment, means that you have institutionalized that knowledge. There is a discrete described way of how to get the system stood up, which means we won't reach the point where no one knows how it works, because of the fact that the code itself knows how it works. And finally, technical documentation here, right? Like, let's go in, and if there are architectural complexities, things like that, give us the documentation that gives us the big picture, because oftentimes the individual unit is too fine a grain. But these three things, automated unit tests, automated deployments, technical documentation, they can help avoid this lack of trust of not knowing how a thing works. All right, next one is one of my favorites. We don't know why it does this to begin with. I love this. This happens way more often than you would think. And it happens first and foremost, I'm afraid to say, for a non-developer reason. It often happens because of the fact that the requirements that are gathered for a software system are not focused on the what, they're focused on the how. They are not focused on what needs to be done to make the business successful. They're focused on the how someone would like it specifically implemented. And it is really important to capture those what-based requirements to make sure that you are explaining what we're trying to accomplish. Because any code that's written, if it can't tie back to a big picture what, it probably doesn't need to be written. It's probably code that's there for no reason. Now, if you're immediately like, hold on, Rayburn, you say that everything should tie back to those big picture what requirements, but we need to make sure that things have dependency injection and It's like, yep, there are a bunch of technical based what requirements as well, but the what requirement for dependency injection is perfectly explainable to a big what of we need to be able to evolve and change this system rapidly over time. That's the what. You'll note nowhere in there was their dependency injection, nowhere in there was their interface-driven development, abstract factories, or anything of the sort. Nope. We need to be able to change and evolve the system over time. That's the what. The how of that is dependency injection, interface development, and a bunch of other things that can lump into the support of that what. But we need that what at the outset. And if we capture those requirements and can find those requirements, then we're less likely to get into the we don't know why it does X, because of the fact that the reason for X should be in those requirements. Now, the other reason that this comes up is because of the fact that between the what and the how, the binding gets lost. So if you have a requirement that states that when we're processing a particular type of job through our system, that it needs to perform X, Y, and Z operations, that what needs, when we get to the how of the written code for that, we should leave ourselves comments that say, by the way, this is in support of that what, and point back at the requirements. This is the comment I love the most and see the least. A comment in the code that says the business requirement for why this line of code was written is located here in our requirement system. The other one that causes this, we don't know why this does this, is a definite software design failure. And this is one we absolutely should try to avoid, which is customization for a particular client's workflow or a particular edge case workflow in the primary flow of the system. If every company has the big client that they made of their system, even if it's an internal client, that they said, yes, we'll handle that for you 15 years ago, and we're still handling that for them. And nobody else cares about this feature but that one client. But if that set of logic, if that set of decisions and logical behavior modifications are occurring in your primary code base, in your primary workflow, then you haven't done your future self any favors, because you've obscured the meaning of your primary flow by interjecting these concerns that are related only to a portion of the people involved. And the way we avoid doing that is we have and use pipeline structures so that we allow those customizations to live only where they need to live. If you think about how ASP.NET handles every type of HTTP request necessary to come in and out of a .NET system, for instance, and this is the same thing that Node does, this is the same thing that Spring does, so this is not just a .NET thing. A request comes in, and there is a pipeline that request goes through, and in that pipeline, things like routing are handled, things like individual logic can happen, but we can have pieces in there that go, hey, I only care if this, I only do anything other than send on to the next piece of the pipeline if this request came from client XYZ. If it came from client XYZ, I'm going to take action, otherwise I won't. Those small, discrete, customizable pieces that slide into an overall pipeline structure allow us to interject customizations, but not make the primary flow ridiculously complex. And you can then write, when you're writing those individual pipeline components in your software, you can create them in a way that you're very clear. Again, point back to the requirement and go, this is only in support of client XYZ. This, and so when you're reading through this as a new software developer 10 years after the system was originally written, you can be like, okay, I'm not caring about XYZ at the current time, so I can just continue past this. So use pipeline structures, use expandable structures that allow customizations to make sure that you don't have to put those customizations directly in your primary logic. It isn't fast enough. Ooh, I love this one. This is, I will admit, I have a client that I worked with recently, and this was the primary reason they decided to rewrite their system. And when I came in, my response was, well, I'm sorry to hear that it isn't fast enough. What's slow about it? And the response was, we don't know. It's a very complex system. It does a lot of stuff for us. Nobody knows which of those sub pieces are slow. They literally had no idea. And this, at the end of the day, is because of the fact that we don't care enough at the outset about monitoring, logging, and defining real APM, application performance management metrics about our new software. We push it off. We go, that's not a requirement. That's not an MVP requirement. We'll come back to that. Define these up front. Care about this from the outset. You'll be shocked how much easier software development debugging is if you have good monitoring and logging in from day one, just for the record. These build your monitoring in, build your logging in from day one. It's worth it. It will make everything else easier. These are largely buy off the shelf options at the current time. Every cloud has good options in this space. Even if you're in a roll your own situation, the Elk Stack, Elastic, Logstash, Kibana is a great option for playing in this space. There are so many players who are just chomping at the bit to provide your development team a already built perfect solution in this space. Use one of them and just choose one. And to be honest, having anything in this space will be much better than having nothing in the long term. Do not let perfect be the enemy of good in this particular space. And then finally, if you do know what is slow, then remember that this is where the cloud was built, right? So building into the cloud for scalability. And this is a little bit of a cheat on my part because of the fact that hiding under the covers here is the cloud is going to force you into some patterns that will let them scale. So this is, I didn't say here microservices for scalability, but you're probably going to be forced into that by a cloud provider who's going to provide to do this, or containerization for scalability. But again, cloud providers will direct you that way. Things that are in the cloud that allow you to handle elastic scale are going to drive you to the correct software development patterns to make sure that you get into a pattern that allows you to just throw more compute at it so that you do not become bound to a particular in-memory location that everybody's sharing that stops you from moving to a second box, etc. The cloud will sort of twist your arm into making sure that you're developing this right to begin with, but there's definitely a lot underneath there to make sure that you're building for scalability. Next piece. This one. This is built on old technology. So this phrase you're about to see me reuse here in a moment, but for this purpose of this phrase, we are using this for when the system fails. And this is where I get real about talking to software development organizations and go, Too many software development organizations don't even think about what long-term support of their software and the packages that they are using looks like. And they certainly don't take, even if they're aware of what long-term support is, how they should expect it to behave, they definitely don't look at a library or component that they're going to use and ask whether or not its release cycle is anywhere close to the same cadence and care that your release cycle is. And I'll give you an example. If you're a healthcare organization, and I'll pick on healthcare because they're somewhat notorious for, like, we release twice a year at most. If you're a healthcare organization and you have a front end that is built on Angular, as an example, I am here to tell you that by the time you even think about moving on to a new version of Angular, you will almost certainly be out of long-term support for Angular. Angular is a great package, but it's a great package that's developing and moving very quickly, and their long-term support window in the grand scheme of system lifetimes is not very long. If you're taking on Angular, or to be honest, React or Vue both, you're going to be in a situation of signing up for keeping up to date with those package releases and moving it forward. And if you let it get to the point where you haven't thought about the version of Angular you're on and it's 5 years later, there is going to be no easy forward path. The development teams of these packages try to make it easy to move step to step to step with them as you move through that journey. But if you're not releasing at anything close to the same cadence as they are, then suddenly you're going to be like, oh, it's our new release and there are 4 versions of Angular to apply. Well, it's a bad match to the cycle that you're on. So think about how your organization's deploy cycle and the deploy cycle and release cycle of the libraries you're using, how they match up. Talk about this before you get into it. Think about these things before you select libraries. Don't just go, well, of course we're on Angular. Think about this. Make sure that you're ready for signing up for the work you're signing up for. And of course, underlying that is the third bullet point here. The problem is largely generated from an infrequent deploy cycle. So let's examine why we're on such an infrequent deploy cycle. Let's challenge that. Let's push for more frequent deploys, because the more frequently you're deploying, the more quickly you can respond to changes. And we can all say, hey, our software doesn't change very often. I really see no reason why we would need to deploy more than once a year or twice a year. That's all well and good until you run into, a critical vulnerability in a widely used library. Java Stack just had this happen recently with one of their very popular logging libraries, where suddenly everyone had to go and revisit because of the fact that there was a script execution vulnerability that if you knew a particular piece of input was going to be logged out into a logging message, you could stick something in there and start attacking the system that is behind it, and start working your way towards gaining root access just because something got logged. So think about this. Realize that your deployment cycle is not always in your control. Make sure that you care about these patches, that you're paying attention to when this is going to happen or when these types of incidents occur. If a critical vulnerability is discovered in one of the packages you use, would you even know? Would it have to make headline news for you to be aware that there was a problem with library of Express middleware that you're using in one of your applications. And so you have to think about this, and think about this often, because in this modern security world that we live in, you don't get to choose when you need to update these packages. You're going to have your hand forced at some point where you need to do this deployment. You need to do it, and you need to do it sooner rather than later. And if you're in something that's truly critical infrastructure, you may very well face a unfortunate situation of having to say, yep, it's going to take us 2 weeks to be able to check everything that's going on in our production environment to make sure that that library isn't being used. And because of that, we have to simply turn off this system for 2 weeks because of that. That is a horrifically bad break of trust from a business to IT relationship perspective, and you need to do everything you can to avoid this. So you need to make sure that you're not finding out about these vulnerabilities on the front page of the New York Times. Be plugged in to the communities of the components you're using so that you know when this is happening. All right, well, we've gone over a set of reasons why systems fail. Well, one of the other reasons why we eventually retire systems is because there have been people failures along the way, or business failures along the way. And so I want to spend a few minutes talking about that today as well. So we're going to go through 3 of these, and the first one might seem familiar to you. This is built on old technology again. We're also going to talk about everyone wants to work with ... and then finally, we should just build this ourselves. These are these are all reasons that systems get thrown out and new things are built. So let's talk about, from a people perspective, this is built on old technology. Whenever I hear this, if it is not actually built on old technology, aka we're having long-term support issues and things like that we just covered a moment ago, the next most likely thing is that what's going on here is resume-driven development. The development organization has been sold a bill of goods that their people want to learn about and use a particular piece of technology, and they are going to use this as an excuse to get rid of an existing system simply because of the fact that they want to work with this. I understand it's a fast-paced world, a changing world out there where technology is being invented and modified and growing constantly. I have my favorite joke. In the course of this presentation, there have probably been 3 new JavaScript libraries launched. This industry changes ridiculously fast. I appreciate that, but that's a reason to invest in the education and growth of your people. That's not a reason to rewrite systems. And a system that is doing its job should be left to do its job. Rewriting software is ridiculously expensive. So we need to avoid resume-driven development. We need to not be pushing the business to rewrite systems just because of this. We also need to appreciate the actual cost of what a rewrite is going to mean. Every rewrite effort that I have ever been a part of has taken significantly longer than it was forecasted to begin with. Because we tell ourselves stories like we know all the requirements because we have the working system. Nope, I bet you don't. I bet you're closer to that absolutely nothing section of the pyramid that we talked about earlier than you believe you are. If you have not built yourself, if your existing system is not built for retirement, it is probably going to be a very costly endeavor to do the rewrite. And almost no development organization actually monitors the total cost of ownership of their application. Like, how much does it cost day to day for business to be done? And you need to recognize that a rewrite effort is going to be additive to that cost. because you're going to engage in the rewrite, but it doesn't mean that you get to stop maintaining the existing system. Business still has to get done, and until the rewrite is complete, you can't do this. So doing this just for we have new technology we want to use, it's not a particularly compelling reason to go through this. And it's something that you should probably just nip in the bud and tell your software development teams, we'll have some cool new work coming down the pipe, but we're not going to rewrite a working system just because of the fact that we think its technology is slightly older. Another version of this is the everybody wants to work with XYZ. And this is usually done as it's impossible to recruit for this, if it's impossible to find people who are willing to work with such and such technology anymore. And the reality is that if you're actually within the long-term support of your libraries, if you cared about this from a systems point of view, you're probably not actually in this situation. There's some storytelling going on. If you have failed on a system side for how old your technology is, and such that you're dealing with technology that's outside of long-term support, then this may be a real thing. This may be you just can't find people who are willing to work on that older stuff. And it's the reason why staying current with your libraries and your long-term support and picture is so important. It affects your ability to recruit. I am willing to bet that if I asked most software development managers what they felt the relationship between their software packages and their recruiting was, very few people would point this one out to me. And yet this happens, and this is real. So we need to make sure that from a technical point of view, we're staying up to date so that this doesn't become a reality. But if that's not a reality, if you are in long-term support, then this is most likely just resume-driven development again. This is most likely that same excuse of I really want to work with the new thing, not that there's actually a compelling technical reason to work with a thing other than it makes my resume better, it teaches me a new skill set, and I would like to learn that new skill set. Answer resume-driven development with leaning into teaching and educating your employees. Give them opportunities to exercise new skill sets. Make sure that they don't just languish away. Every technologist knows that their skill set is aging every single day. The half-life on knowledge in software is shockingly short compared to many industries, and you need to be prepared for helping your employees keep up to date with this. But don't do that by simply rewriting systems that don't need to be rewritten. And then the final one. And I make it this final point here today on the presentation just to drive this point home. But we should just build it ourselves. Almost certainly not true. Not true most of the time. Buy new software. If there is an off-the-shelf solution that is even close to capable, buy. The cost of software development is absurd. Maintaining your own internal CRM versus paying one of the excellent, well thought out, highly robust platforms that are out there to have access to them, the licensing costs are trivial by comparison. If you need even a fractional amount of the capabilities of Salesforce, pay for Salesforce. If you need the ability to handle Word documents and presentations and things like that, pay for Office 365. Don't build your own. Now, those are extreme, obvious examples that everyone would agree with. But I'm here to tell you the same problem exists when somebody says, oh, well, we should build our own monitoring libraries for this to make sure that we can keep track of things. Why? Between App Dynamics, the Elk stack, Grafana, Prometheus, so many options out there that allow you to get pictures of what's going on without having to write any of it yourself. Why would you bother to write this yourself? You're not that unique a snowflake. You must remember that you are here to to write software only for the things that are your competitive advantage, the things that aren't available in the marketplace at large because they are what define your unique value proposition to your customers. Anything else you should be buying. We don't build our own operating systems anymore for this reason. We don't build our own databases anymore for this reason. The purchased software space is where every technology solving problem should start, with the can we buy a solution to this? And if the answer is no, the follow-on should be, is this actually a competitive advantage for us? If yes, then fine, let's talk about what the possibility of writing software is. If no, then change your process to comply with the software offerings that are out there. If you're not going to get a competitive advantage out of the way you do things today, change how you do things. Don't go write software to support a non-competitive advantage. And so with that, we're at the close of my scheduled presentation. So Jeff, did we have any questions come in that I can answer?
I am. Thank you, Tim, first of all, for the presentation so far. I'm watching the Q&A window right now. Nothing has come in yet, but I did have one that maybe if you have time, you can answer.
Sure.
Do you have any guidelines when rewriting a legacy system? Maybe how much time to spend implementing pre-existing functionality that was in that pre-existing system versus new features? I know clients try to always add in new things. Do you have any guidelines on that to help the rebuild of that system?
No, I think it really is more it's not about like the balance between legacy features versus new features. I think one of the advantages to a business of doing a rewrite is that they get to sort of update their domain to how they think about business now versus how they thought about business 10 years ago. I think instead it is really about what the cost is actually going to look like versus the incrementally evolving their existing system. And this is one of the things that I mentioned I covered in my my blog post where I talk about rewriting systems, is go through the analysis of really asking the question, really studying in depth, what would it take to evolve my existing system into the system I want? Because one of the great advantages of the evolutionary method that often is left as, oh yeah, I guess that's an advantage, but is actually critically important, is the fact that the evolutionary method will wind up releasing software very regularly. And the complete rewrite might be a year or two before any real customers see the complete rewrite, because you have to rebuild so much of the existing basic functionality that works on the existing system before it's even usable for a customer on the new system, before it's worth putting even your most simple clients onto the new version of the system. So I think you need to just look at the hard balance of how to do that. And one of the things that I mentioned in that post was the analysis for what it will take to evolve the current system shouldn't be done by consultants. I know this is shocking. I'm a consultant and I'm saying, don't give us that business. Don't give us that business. We're going to walk in and be not as capable of really understanding what it will take to evolve that system compared to the team who has been living with the maintenance and support of it already. Give that effort to your team. They know where all the landmines are. They can give you the actual real number that it's going to take to dig in and solve those problems. So let them do that analysis because they know your existing system best. Anything else?
I think that's a great answer. And you're right. Any chance to deliver early and deliver often will help those projects succeed. So no, as of right now, no other questions are coming in. So I think maybe we'll wrap it up here.
Yep.
Unless you have any last words before we go.
Yeah, I would simply say that I would encourage everyone to look out and check out the Improving Edge conference that's coming in June, and to register for some of the sessions for that. I believe that registration is now open, and you should definitely look. We have some amazing speakers who are going to share some knowledge with us across that first week in June. So go find the registrations for links for Improving Edge and join us for that. And of course, join us next week for the virtual Lunch and Learn here every Friday at Improving.
Well, thank you, Tim, and thank you everyone for attending Improving's virtual Lunch and Learn series today. Thank you, Tim, for sharing your knowledge and expertise. As a reminder to everyone on the call, the recording of this session will be available the next business day at our improving.com virtual events page, so you can check it out there. And thank you again, everyone, for your time today, and we all hope you have a wonderful weekend. Have a good day.